Welcome to The Explainer. Today we're doing something pretty epic. We are going on a journey to the very edge of time itself. I mean, from the absolute first flash of creation all the way to the silent, distant end of, well, everything. You know, it all starts with a question, right? One that I think connects pretty much every single one of us whenever we just look up at the night sky. And that question is, where did all this come from? Now, to even begin to tackle that one, we have to go back. I mean, way back. As far as it's possible to go, right to the very, very beginning.
So let's set the scene. Our story kicks off 13.8 billion years ago. And you got to wrap your head around this. This is a moment before time even existed. It's where all the space, all the energy, everything we've ever known just bursts into existence from this single, impossibly hot, impossibly dense little point.
All right, so let's dive right into that first moment, what we call a flash of creation. Now, scientists call it the Big Bang, but here's the thing that gets a lot of people. It wasn't an explosion in space, it was the explosion of space itself, a crucial difference.
Okay, so the early universe was just this frenzy of creation. It's hard to even imagine. In the very first second, poof, fundamental particles, things like protons, they just snap into being. Then, just 3 minutes later, those particles are already starting to fuse together, making the very first elements, hydrogen and helium, the stuff that would one day build stars. But for the next 380,000 years, the universe was basically this thick, glowing fog. No light could get through, it was just soupy. Until finally it cooled down enough for light to break free and travel for the very first time. And the craziest part? That first light, it's still traveling across the universe today. We can actually see its faint afterglow, which we call the cosmic microwave background.
And get this, that expansion, it never stopped. In fact, it's happening right this second as you're listening to this. The very fabric of space itself is stretching, almost like a balloon being blown up, carrying all those distant galaxies further and further away from us and from each other. Okay, so we have this expanding, cooling universe. What happens next? Well, let's see how all that stuff started to clump together, forming these brilliant cosmic factories that would finally light up the darkness. I'm talking, of course, about stars.
Every single star you see up there has this incredible, dramatic life story. It all starts when gravity starts pulling together these huge, swirling clouds of gas and dust. Then, for billions of years, the star lives its life by doing one thing, smashing hydrogen atoms together to make helium. It's this constant, brilliant engine of nuclear fusion. But for the biggest, most massive stars, the end isn't quiet. Oh no. They go out in one final, absolutely spectacular explosion called a supernova.
You know that saying, we are all made of stardust? Well, it's not just some nice poetic phrase. It's the literal truth. Those supernova explosions, they're like cosmic forges. They're so unbelievably powerful that they create all the heavier elements, things like carbon, oxygen, iron, and then they just blast that stuff all across space. And that material, that's the exact same stuff that eventually formed our planet, our bodies, you, me, all of us.
So, okay, let's pull back from that huge cosmic scale for a second. Let's zoom way, way in to our own home, our rare blue dot, this very special place that formed from that exact stardust about 4.6 billion years ago. Think about this number for a second, 100,000 light years. That is the staggering diameter of our home galaxy, the Milky Way. You could think of it like this sprawling, spiral city made up of over 200 billion stars. And our sun? It's just one of them, kind of tucked away in a quiet suburban arm of the galaxy. And even within our little corner of that galaxy, our solar system has these two totally different neighborhoods. You've got the inner planets, close to the sun, the small, rocky worlds like Mercury, Venus, Earth, and Mars. Then you cross the asteroid belt, and suddenly you're in the land of the giants, these massive balls of gas and ice like Jupiter and Saturn. Each one is its own unique world, but one of them is really, truly special. So what makes Earth so unique? Well, it's not just one thing. It's more like this delicate, perfect storm of conditions. A cosmic recipe, if you will. You've got liquid water, which is huge.
You have a protective atmosphere we can actually breathe. There's a magnetic field that shields us from all sorts of deadly solar radiation. And we even have this churning, molten core that drives things like plate tectonics, recycling our continents. As far as we can tell, in all the universe we've looked at, finding this exact combination, well, it's exceptionally rare.
Okay, so now that we're grounded here at home, let's zoom back out again. Because beyond all the stars and the planets that we can actually see, the universe is dominated by these vast, invisible forces, deep mysteries that we're really only just beginning to get a handle on.
Let's talk about black holes. These things are basically the universe's ultimate gravitational traps. They form from the collapsed cores of massive stars, and their gravity is so strong that absolutely nothing, not even light, can escape once it crosses that boundary, the event horizon. Now, we can't see them directly, of course, but we can see the crazy effects they have on nearby stars and gas. And get this, there's a supermassive one, millions of times the mass of our own sun, sitting right smack in the center of our own Milky Way galaxy.
But as weird as black holes are, they're just one piece of a much, much bigger puzzle. This is one of the biggest bombshells in modern cosmology. It turns out that if you add up all the stuff in the universe, every star, every planet, every person, everything we can see and touch, it only accounts for 5%. Just 5%. The other 95% is a total mystery. We call it dark matter and an even stranger thing called dark energy, which seems to be this invisible force that's actively pushing the entire universe apart.
So, trying to understand what the universe is made of, especially that really weird and dominant dark energy, is the key to figuring out its ultimate fate. So, how does this grand story end?
Well, scientists have a few main theories, and honestly, they're all pretty chilling. So, will it be what they call the Big Freeze? That's where the universe just expands forever and ever until the last star finally burns out, leaving nothing but a cold, empty darkness? Or maybe a big crunch, where gravity eventually wins the tug of war and pulls everything back together in one final fiery collapse. And then there's the big rip, where dark energy gets so strong that it literally tears apart galaxies, stars, and eventually the very atoms of reality itself.
So, which one is it? Well, right now, based on all the evidence we have about how fast the universe is expanding, all signs are pointing to the Big Freeze. It wouldn't be a bang, but a slow, quiet fade into a cold and silent darkness, trillions upon trillions of years from now. So when you think about it, from that first tiny spark of the Big Bang, all the way to a potential endless freeze, we are just this brief, fleeting moment of consciousness in an absolutely astonishingly vast cosmos. And yet, through our curiosity, our relentless need to know, we can actually piece together its story. The universe is still so full of shadows and mysteries, but you know what that means? It just means our incredible journey of discovery has really only just begun. What are we going to find out next?